and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 4, Lesson 7 on messy percentages. That's right, percentages, which are already kind of messy in the first place. We're going to make them even worse. And what I mean by that is that many of the percentages that we've worked with so far, in fact, I'd go so far as to say all the percentages we've worked with so far, both in Math 7 and in Math 6, have always been whole number percents. So, we've talked about someone's pay increasing by 8%, or we've talked about a 15% tip on something, right? But there's no reason why percentages have to be whole numbers. There's absolutely no reason why you couldn't have, let's say, a tax of 3.5%. In fact, I think that the tax in the county that I live is 8 1/8%. That's 8.125%. All right, so percentages can be messy, and today what we want to do is we want to look at some of those. All right, and as always, we're going to have our calculator handy to make that work a little bit easier. But let's get into our first exercise where we try to kind of introduce the idea of a messy percent in a way that hopefully will make some sense to you. Let's get into that in the first exercise. All right, percent values do not have to be whole numbers. They just don't. Exercise number 1. The sales tax on gasoline in one county is 7%, and in another county it's 7.5%. Jeremy wants to buy $16 worth of gasoline and would like to calculate how much he will need to pay in taxes in both counties. Letter A, what can you multiply 16.00, or just 16, by to find the 7% tax, expressed as a fraction and as a decimal? All right, well, this is easy enough, right? We've been doing this for a couple lessons now. Right, if I want to find a 7% tax, I could either multiply my 16 by 7 divided by 100, or 7/100ths, or in decimal version, I could multiply by 0.07. And again, if this confuses you at all, if you thought, oh, I should multiply by 0.7 and not 0.07, of course, don't hesitate to grab that calculator wherever it is, right, and just do 7. Let's try that again. 7 divided by 100, and we get our 0.07. So make sure you're not thinking 70%, but you're thinking 7%. Now, letter B. Determine the 7% tax on the $16 by setting up and evaluating a product. Use your calculator to speed up the process. All right, simple enough. Let's do this together. As we know, right, we can find 7% of 16 by just multiplying the 16 either by 7/100ths or by 0.07. We're going to go with the decimal, as we have been lately. So we're going to do 0.07 times 16. And we could have 16.00, but that really makes no difference. So we're going to do 0.07 times 16, enter, and we get 1.12. So we find that the tax, that 7% tax, ends up being $1.12. All right, simple enough. But now let's extend this and think about what's going on with a 7.5% tax. Letter C. What can you multiply 16 by to find 7.5% tax? Express as a fraction and as a decimal. The fraction may look a little bit strange. All right, I'd like you to pause the video, and I'd like you to think about what we did in A and kind of mimic it in C, because it's exactly the same idea. Pause the video now and write down both the fraction and the decimal. All right, well, here we go. The fraction had been 7 out of 100. Now the fraction is 7.5 over 100. And this is where I mentioned that it might look a little strange, right? We're used to, when we have fractions, seeing a whole number in the numerator and a whole number in the denominator. But there's actually nothing wrong, because fractions are division, with having something like 7.5 divided by 100. Now, not surprisingly, if we want to know the decimal version of that, and I did 7.5 divided by 100, right? Notice we now have 0.5 0.075. Right? And that's it. There's our messy percent, right? So now instead of multiplying by 0.07 in letter D, we're going to be multiplying by 0.075. So why don't you go ahead and pause the video now and figure out what 7.5% of 16 is. Okay, well let's do it. It's going to look exactly like this calculation, except instead of 0.07, that decimal's a little hard to see, but instead of 0.07, it's going to be 0.075. All right, so easy enough. Maybe make that decimal point a bit more obvious. 0.075 times 16. Let's do that on our calculator. Clear that out. 0.075 times 16. Enter. We get 1.2. Now again, keep in mind that we're talking about dollars here. So that's going to be $1.20. By the way, this answer should seem reasonable to me, right? 7.5% should be pretty close to 7%. Here I've got $1.12, here I've got $1.20, and I feel comfortable because that's a bit larger than that one, right? But that's it. That's the whole idea, right? We can have percents that have decimals in them themselves. And I'm not talking about the decimal version of the percent. I am literally saying we can have 7%, we can have 3.25%, we can have 4.18%. That's all okay. It just means that what we're dividing by 100, right, has a decimal itself in it. Let's see this a little bit more in every other problem that we're going to do in this problem set. All right, let's take a look at exercise number 2. For each of the following scenarios, answer the percentage questions by setting up an appropriate product and evaluating it using a calculator. Letter A. A total of 125 people attended a 7th grade basketball game. Of those, 83.2% came early. How many people came early? All right, we want to find 83.2% of our total of 125. So what we want to do is we want to convert our 83.2% into a decimal. All right. Now again, the way that I want to think about that is 83.2% is 83.2 divided by or over 100. Now, again, if you get at all confused about how to convert this, it's really just moving that decimal place 2 places to the left, as it always has been with percents, because we're dividing by 100. But it's also easy enough to take your calculator and simply do that division there. Again, all we ever do when we convert a percent into a decimal is take the decimal point and move it 2 places to the left. So that 83.2, right, becomes 0.832. And I'll start doing that more and more and stop writing down this fraction and kind of doing it on the calculator. But now we want to find 83.2% of 125. So now we're going to just do 0.832 multiplied by 125. No doing this one the long way because that would take a while. 0.832 times 125. And we find that 104 students, or 104 people, must have come early. That's it. All right? So there's really nothing different that we're doing here than what we did in the last lesson. There really isn't anything different. But the percent is just a bit uglier, right? 83.2%. Let's take a look at letter B, and let me get my calculator out of the way so you can read it. Letter B. A bank account has a total of $4,750 in it. A customer withdraws 4.8% of that total after a year. How much did the customer withdraw? All right, great. So again, a messy percent, 4.8%. What I'd like you to do is pause the video now and see if you can find out 4.8% of that total, 4,750. Pause the video now and see what you can do with it. All right, well again, my first step is really to take my messy percent, 4.8%, and turn it into a decimal. As I mentioned, right, 4.8%, if I want that as a decimal, we're going to move that 2 places to the left, and that's going to be 0.048. Right, 0.048, we're going to multiply that by 4,750. All right, let's see what we get with that. Clear out our last calculation, 0.048. Come on, 8. Nope. There we go. Times 4,750. And we find 228. Now, of course, the thing that we have to be very careful about, especially in a problem like B as opposed to a problem like A, right, is it could be very easy to accidentally multiply 4,750 by 0.48. By seeing, those two numbers and just saying, well, I know there's a decimal point and then I put the percent afterwards. So 4.8, so 0.48. But we're always taking that decimal point and moving it 2 places to the left. So in this case, giving us that 0.048. That's exceptionally important. All right, let's keep moving on. More work here. Exercise number 3. In a middle school that has 800 students in it, 196 of the students walk home from school. Letter A asks us to write a fraction that represents the portion of students who walk home from school. Use the calculator then to turn it into a decimal. All right, so in the previous problems, we were looking at percents that had decimals in them, right, like 4.8%, and we were trying to find the part of the total that percent represents. Now we're going to go a little bit in the opposite direction. Now I have a total, 800 students, I have a part, 196 of the students, and I want to come up with the percent, right? And we're going to be kind of getting into that in letter B. But first, the fraction, right? The fraction of students who walk home from school is simply the total that walk home from school divided by the overall number of students. So the fraction, very simple. 196 divided by 800. Okay, that is easy. Part divided by total is the fraction the part represents. Now the decimal, right, we're going to use our calculator to do that. There's no way I'm doing this with long division. I mean, I could, but only on a Saturday morning. Let's see, if I have 196 divided by 800, it's not actually true, I wouldn't do that on a Saturday morning. But I get 0.245, right? That's the decimal that fraction represents. Now let's take a look at letter B. What percentage of the students walk home from school? What can you multiply your answer from A by to easily find this? All right, so let's talk about this, right? Here's the fraction of the students who walk home from school. Here's the decimal version of that fraction. I now need to know what percent that represents. Pause the video now and see if you can figure that out. All right, well hopefully you said 24.5%, right? We've been doing a lot of this going back and forth between percents and decimals, right? So this just represents 24.5%, and again, we can just multiply there we go, just by multiplying by 100. All right, so anytime you have the decimal version of the fraction that the problem represents, if I want to take that decimal and I want to be able to more easily think about it as a percent, nothing prevents me from just multiplying by 100, and then I have that percent, 24.5%. All right, now, many students get good enough, especially given all the work that we've been doing with percents and decimals, at just looking at this and going, 24.5%. And I would certainly expect that if that 5 wasn't there, if that was just 0.24, I hope all of you would say 24%. What worries me sometimes when things are like this is that you might have a student who says 245%. You know, so they're just kind of reading off whatever's after the decimal point and then putting a percent symbol on. And that's a little dangerous. So if you're confused about it all, take the decimal that fraction represents, right, or the decimal version of that fraction, if you will, multiply by 100, and that will literally then just give you the percent right on your calculator, per 100. All right, let's keep going. Problem number 5. Exercise number 4. I don't know why I said problem number 5. Exercise number 4. Often you want to determine the percent of the points you earned on a test or a quiz. All right? These percentages are often messy and are then rounded to the nearest whole number. For each of the following scenarios, determine the percent a student would receive. Show the fraction, the decimal, and the final percent for each. Round your percent to the nearest whole. All right. Now, this literally could be the kind of first exposure you ever got to percents. I have kids myself, I saw them as young as being in like first grade, and they'd get a test back and they'd have like a 30 out of a 35, and the teacher would write a percent on their page. They wouldn't have any idea how that percent was calculated, but they'd know that was the percent they got. But now we do know, right? So in letter A, when I get 23 out of 28 points on a quiz, right? The 23 is the part, the 28 is the total, so the fraction that the student got was 23 out of 28. Now, the decimal, of course, I'm going to use my calculator on. 23 divided by 28 equals, and I'm going to write down a bunch of decimal points, but obviously I'm not going to take my time and write down all of these. And I'm going to indicate that by putting a little dot, dot, dot afterwards. And now I want the percent. All right, now, again, if this had just been 0.82, I would expect everyone to just say 82%. But it's not 0.82, it's messy. It's 0.8214, et cetera, et cetera. Now, if I multiplied this by 100, right, if for some reason I needed to do that, there we go. If I multiplied it by 100, right, then I'd get 82.1428, etc. percent. This particular problem, because it's all about grades, and often when we get a grade back on a test, our teacher doesn't say we got an 82.1428%, they round it to the nearest whole percent. That's now easy. I can just look at this and go, well, since it's 82.1, everything else doesn't matter. 82.1, I'm going to round that down to 82%. But it's really that simple, right? And you'll get to a point with percent problems on tests and quizzes where it's just the first thing you do. You know, you take a math test, you get it back, you know, your teacher says, hey, you got a 66 out of an 85 on this test, right? You know, that doesn't mean you got a 66%. That would only be if you got 66 out of 100, right? And you're going to want to know, oh, what did I get on this test? Oh, 66 divided by 85. And that will then tell you your percent. All right, let's do one more of them together and then have you do the last two on your own, right? So if I got a 66 out of an 85 on a test, clear that out, right? Then the fraction that I got correct was 66/85. All right, let's see what that is as a decimal. 66 divided by 85 is 0.7764, etc. None of these are nice. If I then multiply that by 100, I'm going to get 77.64, etc. percent. And if I now round that to the nearest whole number, that this time is going to round up to 78%. Right? So it's simple. Part divided by the whole gives you the decimal portion, right? Then multiplying it by 100, you then figure out the percent. And again, it's very, very often the case, especially if teachers give you a test that's not out of 100 or 50 or 25 or 20, your percentages are going to be kind of ugly unless you get 100% every time. Then that's pretty easy. Anyhow, what I'd like you to do is pause the video now and figure out what percent you got on this project if you got a 41 out of a 45, and what percent you maybe got on a spelling test if you got 13 out of 18. Pause the video now and see what you have. All right, let's do it. So 41 out of 45. First things first, our fraction, 41 divided by 45. Great. Let's now get a little decimal going on. 41 divided by 45. Ah, I love that. 0.91, looks like that 1 is repeating. If I multiply that by 100, I'm going to skip that process on the calculator. It would move the decimal point 2 units to the right, giving me 91.11%, and rounded to the nearest whole percent is a 91%. Good job, 91%. Awesome. All right, on the other hand, if you're like me and you took a spelling test and got only 13 out of 18 words correct, right, let's see what you would have gotten on that. So 13 divided by 18 would be the fraction that we got. Let's figure out what decimal that is, 13 divided by 18. That gives me a decimal of, again, another repeating one, 722, etc. If I multiply by 100, that gives me 72.22, etc. percent. And now if I round to the nearest percent, that's 72%. We don't always want to round to the nearest whole percent. It's just within this context where we're talking about like a grade that we might get on something that it probably makes sense to round to the nearest percent. All right, let's get this out of here and do one last problem. Exercise number 5. On her 120-point final exam, LaTanya needs above a 90% to secure an A for the course. If she scored 109 points, did she earn an A? Justify your response. Awesome. Pause the video now and see if LaTanya earned an A. All right, well, let's do it. So we've got 109 points out of 120. So the first thing I'm going to do, just like I did in the last set of problems, is I'm going to set up my fraction, right? 109 over 120. All right. So we want to figure out what that is as a decimal. 109 divided by 120 gives me 0.90833, etc. Whoops, there we go. Which would be 90.833, etc. percent. Hello, red. And that would be a 91% if we rounded to the nearest percent. We don't even have to round to the nearest percent. The plain fact is, yes, because she got higher than a 90%. Not much higher, but the plain fact is she got higher than a 90%. And the only way to know that is by setting up that ratio, 109 to 120, figuring out what it is in terms of a decimal, converting that decimal into a percent, and then comparing it to what she had to get, which was that 90%. All right, let's wrap this thing up. So today, what we did is we finally looked at percents that weren't whole numbers anymore. No more 8% or 2% or 17%. Now it's 8.5%, 3.25%, etc. And we found those percentages of totals by doing what we've been doing all along, changing the percent into a decimal and multiplying the total by that decimal. Then we also looked at the corresponding question, which is if we know the whole and we know the part, can we calculate the percent by simply taking the part, dividing it by the whole to get a decimal, then multiplying that decimal by 100 to figure out the percent. Now again, most of the time that doesn't turn out to be a nice whole number percent. Often it's got messiness going on within it. We just have to be able to interpret it correctly. All right, we're going to see a little bit more of this messiness in our next lesson, also on percents. For now, I want to just thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.